In section 4.4, we're proving triangles congruent by two new shortcuts today, side angle side and HL, which stands for hypotenuse leg. So two more shortcuts that will work for proving triangles congruent. First thing we need to know is an important term. We need to know what an included angle is because it'll apply with this side angle side situation. An included angle is the angle formed by two sides or between those two sides. And the reason why we're talking about included angle today is because we're using side angle side shortcut. So if we have two marked sides and we want the included angle, we want the angle in between those two sides. So we'd be talking about this angle here would be our included angle. Okay, it's in between or made by those two sides. And here I want to do a visual reasoning of why side angle side is a valid congruent shortcut. Questioning right now, is it a valid congruent shortcut? Notice I have two sides that I copy and pasted. I have an angle that I copy and pasted. And since we're doing side angle side, the angle is included, is the included angle between the two sides. It is located or formed by those sides. So I'm going to take these two defined sides and I'm going to place them on this angle. Get them to match up as close as I can here. So I'll do my red side there, and this green side, I'll have to match up here. Not quite right. Alright, I think that's about as good as I can do. And so this is a side angle side situation. I would just complete my triangle by putting that last side in, and now I'll group all this. Now again, we'll see if I can make a different triangle. You notice I tilted the angle. It is still the same side. It's still congruent. And maybe this time I'll do the red side off of right here. And I'll put my green side off of this ray. Actually, that looks pretty good. Complete my triangle by putting this last line segment here, connecting those two sides that have to stay that length. And I'll group all this together, and let's see if these triangles really are congruent. It looks like I have to flip one of them. It's not just a rotation here. Alright, now if I rotate a little bit, let's see if these triangles really are congruent because of side angle side. The angle is between those two sides, and yes, these are definitely congruent triangles here. So side angle side works. I tried to make two different triangles, but they ended up being congruent with two given sides and the angle between being congruent. Side angle side congruence postulate says if two sides in the included angle of one triangle are congruent to two sides in the included angle of another, then those triangles are congruent, and I can say that these two triangles I know are congruent. All the sides and angles would be congruent based on side angle side. Again, angle is the included angle or between the two sides marked congruent. Now let's use side angle side in some proofs here. Alright, here's what I'm given. Side BC is congruent to side DA. Let's mark those. BC line segment congruent to DA line segment. There we go. This symbol means that line BC is parallel to line segment AD. So BC and AD are also parallel. I'll put those arrows. I have to prove that the triangles are congruent. Maybe this first one we'll do a paragraph proof, and then I have another one and we'll do a two-column. So I always start with what we are given. So we are given that line segment BC is congruent to line segment DA. Now you notice right there is a pair of congruent sides already. They gave me that. And we are also given that line segment BC is parallel to line segment AD. Okay, that has to tell us something. Now we know that with parallel lines we generally get information about angles. So there must be some congruent angles because of those parallel lines. And if we take a look, these two lines are parallel. This line would be considered a transversal because it hits both. And we do have that Z shape forming. These two are congruent angles because they are a special angle pair off of these parallel lines. If I quick highlight those angles, here's my parallel line, here's a transversal, here's my other parallel line. And yes, those two angles are congruent. Do you remember what kind of angles those are? You should be saying those are alternate interior angles. And I'm going to name those angles. I got to be careful. I can't just say angle B. I would have to say like angle CBD. So angle CBD is congruent to angle, I'd have to name this ADB. Because they are alternate interior angles. By alternate interior angles theorem. Look at that, now we have a pair of angles congruent. So we have these sides marked congruent, now we have these angles marked congruent. We're doing side angle side today. There's got to be another pair of sides congruent. And I hope that you're noticing that the two triangles we're focusing on that we want to prove congruent, triangle ABD and triangle CDB, they share a side. They share this side BD, so I know that it's congruent to itself. I'll just say we also know that the shared side is something that happens a lot. We also know that line segment BD is congruent to itself, basically. Line segment BD by what property? What property says something is congruent to itself? Hopefully remember that that is reflexive property of congruency in this case. So guess what? We got side, angle, side. Now we know from that shortcut that the triangles are congruent. Alright. Therefore, I'll write it just the way they said. Triangle ABD is congruent to triangle CDB by side angle side. Alright, so we did our first proof with side angle side congruence. And let's do another. I said we could do our 2-column here. I'm going to set that up. And then we'll talk about what we're given and what we need to prove here. Statements and reasons. Alright, maybe I'll mark what I was given. I'm given that line segment MP is congruent to line segment NP. So here's MP and NP, they'll both get 1 tick mark. Oh, look at this. Line segment OP bisects angle MPN. This tests whether you know what that word bisects means. Remember that bisect? If you think the word dissect is cutting up, right? But bisect would be cutting into 2 parts that are congruent, cutting in half. So the fact that we're bisecting an angle means we're cutting this angle into 2 congruent parts. What angle are we bisecting? Angle MPN. MPN. P is the vertex, notice. MPN would be this entire angle. We're bisecting or cutting this angle in half. So that's going to tell me actually that these 2 angles are congruent. Okay, we'll get to that in a moment. Ultimately, I'm trying to prove that triangle MOP over here is congruent to triangle NOP. I'm assuming this will be another side angle side situation. But we'll get to that. So I'm going to start out, they told me or gave me that MP was congruent to NP. Those sides were already congruent, that was given to me. Alright, I'll write the second given, that line segment OP bisects angle MPN. Okay, we talked about that word bisect. We talked about what that means, that OP, this line segment, is bisecting this angle I highlighted. It means that we split that angle into 2 congruent angles, so this angle is congruent to this angle. It doesn't tell me anything up here, but it did tell me that angle MPN was bisected. Therefore, I know that those angles are congruent. I just got to be careful when I name them. This would be MPO and angle NPO. And I know that they're congruent. MPO is congruent to angle NPO. Question is, how do I know that? I'm actually getting it from the fact that they told me this word bisect. They said this line segment bisects this angle. So anytime you're getting it from a word, it's from the definition of that word. Definition of bisects. or definition of angle bisector, I guess. Alright, I have some sides congruent. I have some angles congruent. Is there anything else in the picture that I can get because there was no other given? And hopefully you're noticing that the two triangles that you're talking about here share a side. They share this side OP. I know that anything is congruent to itself. I'm putting 2 tick marks there. I do have to state that line segment OP is congruent to itself. It's a side in both triangles. Anything is congruent to itself by reflexive property. Here's property of congruence. And finally, check it out. Side, angle, side. I can now prove what they wanted me to all along, that these triangles, MOP and NOP, are congruent by side, angle, side shortcut. So some excellent proofs here using side, angle, side congruence shortcut for triangles. Quick example, this one's not a formal proof, but you notice we got a circle here, and we got some triangles in that circle. Why are triangles MRS and triangle MPQ congruent? Wow, nothing's marked at all. So I must be using some of my knowledge about circles and maybe some other knowledge that I have. Well, do you notice anything that might be congruent based on previous knowledge? First of all, if I'm in this circle, I can tell M is the center because I have it marked as this point. What would you call MR and MS and MP and MQ relative to that circle? And I hope you're thinking those are all radii, or each one of those is a radius of the circle. So, what do I know about every radius in a circle? Well, all radii are congruent in the circle. So I know that MR is congruent to MS, is congruent to MP, is congruent to MQ. They can all get 1 tick mark. Do you see a special angle pair? What kind of angles are these right here? These are vertical angles, and what do you know about vertical angles? They're congruent. So vertical angles are, oops, apostrophe. So the triangles are congruent by what shortcut? Check it out. Side, angle, side. Side, angle, side. We have the angle located between the two sides, meaning it's the included angle. Side, angle, side shortcut tells us that those triangles are congruent based on the fact that all the radii were congruent, and then we had vertical angles. So another use of side, angle, side. Alright, we're doing a few more things today. We're looking at, first of all, a shortcut that is not valid. Side, side, side does not work. It is not a shortcut that will allow us to prove triangles are congruent, because generally with side angle, you can make 2 different triangles. How is this different than what we just did? Remember, we were doing side, angle, side, so the angle was included or had to be in between the 2 sides. Here, we have 2 sides and the angle is not included, it's not between. And we'll see that right here. Notice these green sides are congruent, these angles are congruent, but with side angle, it's not the side going here. The red side is not going here because then the angle would be in between. I'm doing an angle, then a side, then a side. So if I match up this red segment with the end of the green, oh wow, that was perfect actually. You notice the triangle that I've just formed. Okay, here's my first side, here's my second side, and there's the angle being formed. Now, if I take this red side, the thing is, I don't have to do the same thing I just did. I don't have to go inward. What if I extend the side outward? This angle did not change. All I did was draw the line longer, and now I tilt that red side out the other way. Sorry, I gotta get to the point where this matches up. Not quite perfect yet. Right about there. And now I have a totally different triangle, even though I still have side, and then angle. So I am using side, but it's not a valid congruent shortcut because 2 different triangles can be made. It didn't match up. It's not the same triangle. And I want to tell you a little kind of hint to remember that this one doesn't work. And I had said it before. If you notice, if you flip that word around, or the shortcut around, and you talk about the angle first, then the side, then a side, you're spelling a bad word there. So you'll remember that this one doesn't work because of that. Because it's the naughty shortcut. It's a naughty word if you spell it the other way. But yeah, two different triangles can be made because of the fact that the angle's not between the sides. You can put the side inward towards the angle or outwards with that extended ray. So today, I guess, on the homework, a lot of times they're going to be testing you whether the shortcut is a side angle side or whether it's side angle. You're really going to have to pay attention to whether the angle's between the two sides or not. And I also had said we were talking about hypotenuse leg, so we're just quick reviewing right triangles. Remember, a right triangle has to have a right angle, and the two sides adjacent to the right angle or creating the right angle or next to the right angle are called legs. And remember that that hypotenuse is located opposite from the right angle, and it's going to be the longest side. We just need to know our terms for hypotenuse and leg, because hypotenuse leg is a congruence theorem that works. The reason it kind of gets its own thing, being a right triangle, because if you really think about it, hypotenuse leg, I'm going to go back here real quick. Here's the hypotenuse. I'm just going to highlight one of the legs. This is that naughty SSA we just talked about. Look, side, then the right angle. So if we have a right triangle, we automatically have the right angle congruent, and then we have the hypotenuse and one leg. This is the only case where side angle works, is in right triangles. So that's why it's kind of getting its own special case today. And then I'll make a little note here. If the hypotenuse and leg of one right triangle are congruent to hypotenuse and leg of another, they're congruent. So side angle works here only for right triangles. And then we call it hypotenuse leg instead, not SSA. So are there some congruent triangles? In this case, we do see some right triangles here. Obviously, they're right triangles because they're right angle. These are marked congruent. Now, what would you call these? Are they the hypotenuse or a leg? This is the hypotenuse of each of these, right? And what else is congruent between these two triangles? Well, how about that shared side? In this case, we have the hypotenuse congruent, and this is a leg. So yes, these triangles are congruent by hypotenuse leg. Okay, hypotenuse and one leg here. All right, let's take a look. Here, the right triangles, we must be talking about the right triangles, actually. So I'm going to highlight these. This is the first triangle that we're talking about. And the other right triangle, so that I actually make that right angle, is right here. Hey, do you notice what side overlapped here? They share a side. They share right down here, so I'm going to put 2 tick marks. Notice that I wrote WY equals XZ. Now WY, the tick mark here applies to the entire length. XZ, that applies to the entire length here. And in this case, these are the hypotenuse of each of these. This is the hypotenuse of the yellow triangle. This XZ is the hypotenuse of the blue triangle. And now we have a leg being congruent in both. So once again, yes, these triangles are congruent by hypotenuse leg. So today, talking about side angle side to prove triangles congruent. Talking about hypotenuse leg does work for proving triangles congruent, whereas side angle in general does not work as a congruent shortcut.